Section 5.2, Least Common Multiples, Least Common Denominators, Addition and Subtraction. So to find the least common multiple of 12 and 30, factor first. We need a prime factorization. We need to factor it until it cannot be factored anymore. Each number will be a prime number. 12 is 2 times 2 times 3. We can think of that as 2 squared times 3. 30 is 2 times 15. 15 is 3 times 5. So our least common multiple, we're going to choose each factor that is present in the prime factorization. And we're going to use it the greatest number of times that it appears. There are 2 2's here, there's only 1 here. We need 2 of them, as many as the most. We have a 3 and we have a 5. Now, I'm going to write this out as 2 times 2 times 3 times 5. So we have found the least common multiple, the smallest number that both 12 and 30 will divide evenly into. We know that 12 will divide into it because 2 times 2 times 3 is 12. We know that 30 will divide evenly into it because 2 times 3 times 5 is 30. So, what is our least common multiple? 2 times 2 times 3 times 5? 60. So we choose to find that least common multiple. We use each factor the greatest number of times it appears in the prime factorization. We do a prime factorization first, and then we choose each factor the greatest number of times it appears, as many as the most, I like to say. So find the least common multiple of 24 and 90. Begin with a prime factorization. 2 times 12, and 12 is 2 times 2 times 3. We could write it 2 to the third times 3. 90 is 2 times 45, and 45 is 3 times 3 times 5. So 2 times 3 squared times 5. What is our least common multiple? We need a 2. How many 2's do we need? As many as the most. 2 to the third. We need a 3. How many 3's? 2 of them. 3 squared. And we need a factor of 5 because 90 has a factor of 5. So that gives us 2 to the third is 8 times 9 times 5. That's 72 times 5, 360. That is our least common multiple. And the least common multiple will be the least common denominator of our fraction. Now our first fraction has 12 as the denominator. We want 360 as the denominator. What do we have to multiply 12 by to get 360? 12 times 30 is 360. We cannot just multiply the denominator of the fraction by 30. We also have to multiply the numerator of the fraction by 30. 30 over 30 is 1, so we're not changing the value of the fraction, we're just changing the way it's written. So we have 7 over 30. We need to have 360 in the denominator. What do we have to multiply by this time? 12. So that's going to change both of our fractions. This one will be 150 over 360. This one will be 84 over 360. Now that we have a common denominator, we're able to add the numerators. That's 234 over 360. So now we need to see if we can simplify this 234 divided by 360. Is there a common factor there? I know they're both divisible by 2. So how about we divide numerator and denominator by 2? That will give us 117 over 180. And I think that's our answer. That's as simplified as we can get it. You may be asking yourself, why are we adding fractions in Math 99? Surely, we learned that a long time ago. But we're going to be adding and subtracting rational expressions, fractions with variables. So we need to really emphasize the steps that you take in adding and subtracting fractions. So we're going to be finding the least common multiple of these expressions with variables. We're going to take the same steps we did when it was just numbers. Factor each expression. The least common multiple is the product of each different factor, the greatest number of times it occurs in any one expression. Sorry, I'm wiggling all over the place, but I can't write when it's too small. So let's look at this. We're going to think about, you can think about the numbers and factor them. 12 is 2 times 2 times 3. 9 is 3 times 3. 15 is 3 times 5. So we'll factor each expression. Our least common multiple, we need a factor of 2. How many? The greatest number of times that it appears. We need a factor of 3. How many? The greatest number of times. And we need a factor of 5. We need a factor of x. What is the greatest number of times that x appears? X squared. We need a factor of y. What is the greatest number of times y appears? 3 times. So 2 squared is 4. 3 squared is 9. 4 times 9 is 36 times 5. 36 times 5 is 180. Whoops. X squared, y cubed. That is our least common multiple. It is the smallest expression into which each of our original 3 expressions will divide evenly. Now we have an interesting problem. We need to look at our 3 expressions here separately. A squared minus a. Our first instruction is to factor this. Common factor of a. What are you left with? That's our prime factorization. A squared minus 1. We need to factor it. Can you do it? Now we have a squared plus 2a plus 1. It's a special product as well. A plus 1 times a plus 1, or a plus 1 squared. So our least common multiple, we want to consider each one of these separately. This is a, this is a factor of a, this is a factor of a minus 1. So our least common multiple needs a factor of a. Let's look at all of our factors. Each underlined component is a factor. There is only one place where a is located. That's right here. There's only, so as many, what's the greatest number of times it appears? Just once. We don't have to write an exponent of 1. We also see a factor of a minus 1 here and here. What is the most number of times that a minus 1 appears in our prime factorizations? 1 time. So we also need a factor of a minus 1, and it will be raised to the first exponent. I see a factor of a plus 1 and a plus 1, so we need a plus 1. We want it to have as its exponent the largest exponent of the 2 times it occurs. It's understood to be raised to the first power the first time it occurs, and to the second power the second time it occurs. The greatest number of times squared, because 2 is the highest exponent. This is our least common multiple. We leave it factored because it's easier to use to do other things. So that's it. That's our answer. Let's look at this problem. What about that x squared plus 9? Can you factor that? That's the sum of perfect squares. You can't factor that. That's prime. You can't factor x plus 3, and you cannot factor 5. So our least common multiple will have a factor of x squared plus 9, a factor of x plus 3, and a factor of 5. Don't multiply it out. Leave it written as a product so we can use it for the next step. That's all for this page. Go on to the next section to get to the next page.